Welcome to another episode in our Ethical Hacking Mastery series. Today, we're exploring a powerful graphical interface for the Metasploit framework called Armitage, which makes sophisticated exploitation accessible through an intuitive visual interface. As always, we'll begin by ensuring our system is completely up to date. Open your terminal and run sudo apt update to refresh our package repositories and check for the latest software information. Once that completes, run sudo apt upgrade to install any available system updates. When prompted, type Y to continue with the upgrade process. Keeping our system current ensures compatibility with all the tools we'll be using and provides the latest security patches. Now we need to install Armitage itself. Run sudo apt install Armitage and press Y when prompted to confirm. The application will download along with any necessary dependencies. With installation complete, let's launch it. Navigate to your Applications menu and search for Armitage. You should see it appear in the search results. Click to launch the framework. Since elevated privileges are required, you'll be prompted to enter your Kali Linux password. The connection dialog will now appear, asking for several configuration details. The default settings typically work perfectly for local use. You'll see fields for host, port, and username. The default username is MSF. For the password, also enter MSF to match the username. Click Connect to establish the connection. You'll now be asked if you want to start the Metasploit RPC server. This server allows the graphical interface to communicate with the underlying Metasploit framework. Click Yes to start it. Starting the RPC server takes some time, as it initializes the entire Metasploit framework in the background. Be patient during this process. It typically takes a minute or two, depending on your system's resources. Once initialization completes, the dashboard will appear, revealing its clean, intuitive interface that makes exploitation significantly more accessible than command-line Metasploit. Before we can exploit any systems, we need to discover what targets exist on our network. The tool integrates Nmap scanning directly into its interface, making reconnaissance straightforward. Click on the Hosts menu at the top of the window, then select Nmap Scan. A submenu will appear showing various pre-configured scan types, each designed for different reconnaissance scenarios. We'll use the Intense Scan option for our demonstration. This scan type performs comprehensive reconnaissance, including service version detection, operating system fingerprinting, and script scanning. Click Intense Scan to proceed. A dialog box appears asking for the IP address range to scan. We need to specify our local network range. Open a terminal and type ifconfig to display your network configuration. Look for your network interface, usually ETH0 or WLAN 0, and locate your IP address. Copy the first 3 octets. Return to the dialog and paste these 3 octets, then add .0/24 at the end. This CIDR notation tells Nmap to scan all 256 IP addresses in this subnet. Click OK to begin. The scan will now execute in the background. Depending on how many active hosts are on your network and the complexity of services running on them, this process might take several minutes. When scanning completes, you'll see a Scan Complete notification. Look at the main workspace area. You should now see multiple computer icons representing all the machines discovered on your network. Each icon represents a live host that responded to our scan. Now we need to identify which of these discovered hosts is our intentionally vulnerable target machine. Switch to your Metasploitable 2 virtual machine window. If you haven't logged in yet, you'll see a login prompt and credentials. Enter these credentials to access the system. Once logged in, type ifconfig at the command prompt to display the network configuration. Look for the IP address. In our case, you can see it ends with the number 4. Return to your attacker machine. Look through the host icons in the workspace and locate the one matching the IP address you just identified. This is our target machine, where we'll demonstrate exploitation techniques. Try right-clicking on the target host icon. You'll notice that no attack options appear in the context menu yet. Click on the Armitage menu at the top of the window, then select Set Exploit Rank. You'll see a drop-down menu showing different reliability rankings. By default, it's set to show only Great-ranked exploits. Change this setting from Great to Poor. Click OK to apply this change. Now we need to analyze our target and determine which exploits might work against it. Click on the Attacks menu, then select Find Attacks. The framework will now cross-reference the services and versions detected during our Nmap scan against Metasploit's extensive exploit database. This analysis determines which exploits are potentially applicable to each discovered host. This matching process takes some time, as the system evaluates hundreds of potential exploits against each service running on each host. When the analysis completes, you'll see a notification stating, "The attack menu is now attached with each host." This means the system has finished its analysis and associated relevant exploits with each target. Now when you right-click on your target host, you should see an attack option in the context menu. This menu organizes available exploits by the service they target. For our first exploitation, we'll target a well-known vulnerability in VSFTPD 2.3.4. This FTP server contains a backdoor that was maliciously inserted into the source code, allowing remote attackers to gain system access. We've covered this exploit in detail using command line Metasploit in a previous video. You can access that tutorial through the info icon. Click on VSFTPD 2.3.4 Backdoor to select this exploit. An exploit configuration dialog appears showing various options for the attack. The default settings are typically appropriate for this particular exploit, so we'll proceed without modifications. Click Launch to execute. The system now configures the exploit module, sets the target parameters based on our scanned information, and attempts to execute the attack. Watch the console output at the bottom of the window. You'll see the exploit progress through various stages. After a few moments, you should see that Shell Session 1 has been established. This means our exploit succeeded, and we now have command line access to the target system through this backdoor. To interact with this compromised system, right-click on the target host again. You'll notice a new option has appeared in the context menu. Shell 1. Click on this option to open an interactive terminal session with the compromised system. A terminal window opens below, providing direct command line access to the Metasploitable 2 machine. The lack of any fancy prompt or branding indicates we're in a basic shell. This is the raw backdoor access the vulnerable FTP server provided. Let's explore what we can do with this access by running several reconnaissance commands that reveal information about the compromised system. First, type ID and press Enter. This command displays user and group identification information for the current session. The output reveals crucial information. We're running as user root with UID 0. This is the most privileged account on any Unix-like system, meaning we have complete control over this machine. Let's confirm this with another command. Type "Who am I" and press Enter. This simpler command just displays the current username, which shows root. This confirms we have achieved the highest level of access possible on this system. Now let's gather information about the operating system itself. Type uname-a and press Enter. This command displays comprehensive system information, including the kernel name, version, and architecture. Let's explore the file system to see what's available. Type ls to list the contents of our current directory. This shows the files and folders present, giving us a sense of where we are in the system's directory structure. This level of access demonstrates the severity of the VSFTPD backdoor vulnerability. With root privileges, an attacker could read any file, modify system configurations, install persistent backdoors, or completely destroy the system. Let's demonstrate a second exploitation technique, targeting a different service on the same Metasploitable 2 machine. This Samba vulnerability is also covered in detail in a previous command line Metasploit video, accessible through the info icon. Right-click on the target host once again, and navigate to the attack menu. This time, hover over Samba to see Samba-related exploits. Click on User Map Script to select this exploit. The exploit configuration dialog appears with default settings. This particular exploit targets a vulnerability in Samba's username map script functionality, which allows arbitrary command execution. The default options are appropriate, so click Launch to execute the attack. The system configures and launches the exploit, again working through the exploitation process in the background. You'll see progress updates in the console area. After successful exploitation, you'll see that Shell Session 2 has been established. This represents a second independent access path to the same target system, this time through the compromised Samba service. Right-click on the target host to see the updated context menu. You'll now see both Shell 1 from our VSFTPD exploit and Shell 2 from our new Samba exploit. Click on Shell 2 to open this new shell session. A new terminal window opens, providing another command line interface to the compromised Metasploitable 2 system, this time through the Samba vulnerability rather than the FTP backdoor. Let's explore what capabilities this second shell provides by running different reconnaissance commands. Type hostname-s and press Enter. This command displays the system's hostname in short form, without the full domain name. This helps us confirm we're interacting with the correct target machine. Now let's check what sudo privileges might be available. Type sudo-l and press Enter. The sudo command allows users to execute commands with elevated privileges. And it's showing all, which means we can run all commands with sudo. Finally, let's examine what network services are running and listening. Type ss-tuln and press Enter. This command uses the ss utility to display socket statistics. The output reveals all network services currently listening for connections on this system. Each line shows a protocol, the local address and port the service is bound to, and its connection state. This information is valuable for understanding what services are exposed and potentially vulnerable to further exploitation. Through our systematic exploitation of two different vulnerabilities, we've seen how penetration testers can efficiently discover, exploit, and maintain access to target systems. This video is part of our ongoing Ethical Hacking Mastery series, where we're building comprehensive penetration testing skills from fundamental concepts to advanced techniques. Each episode builds upon the previous ones, creating a complete educational journey through ethical hacking. If you found this demonstration valuable for your ethical hacking journey, smash that like button right now. Your engagement helps us reach more aspiring security professionals who need this knowledge. Hit subscribe and turn on notifications so you never miss the next episode in our Ethical Hacking Mastery series. Until next time, stay curious, stay ethical, and keep learning. This is Tech Sky, signing off.
One, two, three, make it run， 保救的宝宝里，好长的奶子，我禁止爱死。